Okay, our last type of problem is looking to see whether a precipitate occurs if we have enough ions in solution to actually cause a precipitate. So to determine whether a solid will precipitate, we need to look at the KSP. If Q, which is our KSP at any conditions other than equilibrium, is greater than KSP, a precipitate occurs. And if Q is less than KSP, there's not going to be a precipitate. So these are pretty elaborate problems, and you can definitely expect to see at least one of them on your test. So it says a 200 milliliter solution of 1.3 times 10 to the negative third molar silver nitrate is mixed with 100 milliliters of a 4.5 times 10 to the minus fifth molar sodium sulfide solution. The KSP is 8 times 10 to the negative 51. Will a precipitate occur? The first thing we need to do is write the balanced equation between silver nitrate and sodium sulfide. Okay, so we're going to look for this balanced reaction between silver nitrate and sodium sulfide, which I've put up here now. We have silver nitrate plus sodium sulfide, and we're going to put the silver with the sulfide, Ag2S, and the sodium with the nitrate, NaNO3. And I'm going to go ahead and balance it. 2 Ags, 2 Ags, 2 NAs, 2 NAs, and one of the other two. And then I went ahead and just put this data down. I have 1.3 times 10 to the third molar of AgNO3, and it's 200 milliliters of the solution, and I have 4.5 times 10 to the minus 5 molar, and I have 100 milliliters of that solution. The first thing I need to do is I need to figure out the moles of each of these. So I know that molarity is equal to moles over liters. So I'm going to take 1.3 times 10 to the minus third molar is equal to X moles over 0.20 liters. And so I end up with 2.6 times 10 to the minus fourth, 10 to the minus fourth moles of AgNO3. And this one I'm going to shift over here just a little bit. Same thing. I'm going to take 4.5 times 10 to the minus 5 molar is equal to X moles over 0.100 liters. And I'm going to get 4.5 times 10 to the minus 6 moles is equal to X. And this is moles of, in fact, I'll just make this moles of Na2S. Now, when I mix 100 milliliters with 200 milliliters, my total volume of solution is now 300 milliliters, which means both of my moles have actually become diluted. Because I need to know what my precipitate, will precipitate occur? Yeah, well, here's my precipitate according to solubility rules. Will I have enough of each of these ions to actually make a precipitate? So I need to do the next step, which is the dilution. So once I have my moles, I need to do my dilution. To do my dilution, I'm finding the new molarities. So to find my moles of Ag, my molarity is equal to moles, 2.6 times 10 to the minus fourth moles, over the new volume, which is always formed by adding these two, 0.300 liters, which is equal to 8.67 times 10 to the minus fourth molar. Okay, I'm going to do this one for dilution and my molarity, and this is my molarity of, and this is of Ag plus, because that's what I'm concerned with. Molarity here is equal to 4.5 times 10 to the minus 6 moles over 0.300 liters, which is going to give me 1.5 times 10 to the minus fifth molar, and that's of my S. That's the other thing that I'm concerned with because I'm looking at Ag2S. Now that I have my new concentrations, I have my last part of this problem. Are you ready? I'm looking to do a KSP problem. So I have Ag2S becomes 2Ag plus 1 plus S minus 2. Now it's starting to look a little bit like yesterday. I'm going to write my Q expression, which is exactly the same as my KSP. It's Ag plus 1 squared and S minus 2. I'm going to plug in my values from above. I am not going to double the AG, and that is because that is all the AG that I have. This is a special rule for this type of problem. You're going to recognize it because it's the question's going to ask, will a precipitate occur? So I'm going to go ahead and I'm going to plug in this 8.67 times 10 to the minus 4th. I am still going to square it. And I'm going to go ahead and plug in this 1.5 times 10 to the minus 5th. And Q is going to be equal to 1.13 times 10 to the minus 11th. I compare Q and KSP. If Q is greater than KSP, there'll be a precipitate. If Q is less than KSP, no precipitate. In this case, Q is greater than KSP. Q is 1.13 times 10 to the minus 11, which is greater than 8 times 10 to the negative 51. So yes, precipitate. That is a very long problem, but there's no hard steps, and it's all things that you can do. And obviously we'll be practicing them in class the next 2 days. But you definitely want to have all of this work done and to see how to go through this. But it's always the same steps. You're going to take what you have. You're going to write a balanced equation up here. You're going to solve for moles. You're going to figure out your dilution factor by adding up your total volumes. You're going to plug it into your KSP expression, your Q values, and compare it to what KSP is.